Okay, kids, so today we're going to be working in Chapter 10, Chapter 10 notes. And this is a topic that's one of my most fun topics to teach, but it's definitely confusing to kids at the beginning. It's a very abstract concept because we're going to talk about grams and moles and molecules and particles and formula units and a lot of stuff that's very abstract. So let me just start off and discuss this with you. This is hard for kids to understand, but the question is what is a mole? Now there's okay. So a mole could be this little rodent, that crawls around in your yard and digs up the dirt and is really annoying and looks disgusting. No eyes, blind as a bat. That's a mole. And then also, some people have got moles on their back or on their chest or their neck, and that's kind of disgusting. But those are moles, right? Neither of which is the mole as referred to in chemistry. In chemistry, a mole represents a number. So a mole is a word that means a number. Just like if I said to you, okay, if I said the word dozen, that's 12, right? Well, why is it 12? Well, it's just because the word dozen means 12. The word mole means this number, which is a huge number. As a matter of fact, if you look at that number in another context, you can think about it like this. 6.02, now we said it was times 10 to the what? 23rd power. So what if we did this? 6.02, 1, 2, 3, 4, 5, 6. You see where I'm going with this? Man, my hand's starting to hurt. It's like the number of dates that I didn't have in high school, right? Yeah, no, I got to turn me down. Well, actually, the number of dates that I had in high school would be more like from there to there, right? Just the zeros. But anyway, so this is the number that represents a mole. And if you play the game, you could say this is ones, tens, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions, billions, 10 billions, 100 billions, trillions, 10 trillion, 100 trillion, quadrillion, 10 quadrillion, 100. My gosh, I can't even get that far. This number is so big. You can't even imagine. They say that you could take sand if there was no water on the earth. If the earth was a solid mass of just land, so there was no ocean, just land, you could cover the earth's surface in sand 7 inches deep, and that would be the equivalent of that number of sand molecules. Pretty wicked, right? They say that you could take Coke cans and stack them end to end from the earth to the moon back and forth 21 times. They say that you could start counting 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi, and your life would expire before you ever got to this number, if that's all you did the rest of your existence. It's just a number that's so big we can't even get our minds wrapped around it. And you say, why are we working with that big number? Well, it's because atoms are extremely small. You have to have a huge amount of atoms in order to know, to have an appreciable amount to work with. So, we use the things on the periodic table. We use these elements to make medicines, right? We use sodium in things. We use lithium. We use magnesium. These things have got to be measured out in quantities that we can really work with and appreciate. And so working with the mole allows us to get exact amounts of things. So then let's talk about this. If a mole is that number, let me write it up here so you can see it. A mole is this number. Right? That's equal to 1 mole. Well, here's what else is really interesting and a little confusing. On the periodic table, you have the element lithium, the number 3, which is the atomic number or the number of protons, And then you have this number down here. I don't know if you can see that, but it's 6.91. And every element has a different number down there, 9.012182. You go over here to boron has 10.81. Gallium down here has 69.723. Those numbers mean something. And what they mean is that is the amount of grams, the grams that's equal to this thing called a mole. So for beryllium, it takes 9.012182 grams to make a mole of beryllium. And magnesium, it takes 24.3050 grams of magnesium to equal that 1 mole. And remember, that also means that if I had 9.012182 grams, I would have this many atoms. Because remember, a mole is equal to this many atoms. And grams equal a mole. So if I had 9 grams, I would have a mole, and I would have that many atoms. But for magnesium, it would take 24 grams to make that 1 mole, or that many atoms. For calcium, it would take 40 grams to make a mole, or that many atoms. So this is what doesn't make sense to me. I'm really confused. If it takes 40 grams to make a mole of calcium, how can it only take 9 grams to make a mole of beryllium if both of them are equal to this number right here? Why can the masses be different amounts, right? Why can beryllium be 9 and calcium be 40? Well, let's stop and talk about marbles and bowling balls for a minute. Now, you can't see my hands in this, but imagine, if you will, I'm holding my hands out to the side and kind of with my palms facing the ceiling. And I say to my students, if I have a dozen bowling balls in my right hand and a dozen marbles in my left hand, do I have more bowling balls or do I have more marbles? Well, yeah, the answer is you have the same amount. You have 12 of each, right? You have 12 bowling balls and you have 12 marbles. And then I might ask you, do they weigh the same? Do those 12 bowling balls have the same mass as those 12 marbles? Well, no. And then I would say, how is that possible? Well, isn't it true that one bowling ball weighs a lot more than one marble? So therefore, 12 bowling balls would weigh a lot more than 12 marbles, even though they're both a dozen? Yeah, so let's do elements. If I have a mole of calcium in my right hand, that's going to weigh 40 grams. If I have a mole of beryllium in my left hand, that's going to weigh 9 grams. But they're both equal to what? This number. And you say, well, how is that possible? Well, doesn't one calcium weigh more than one beryllium? Didn't we learn back earlier in the year that that number 4 meant that beryllium had 4 protons? It doesn't also have 4 neutrons? So if beryllium has essentially 8 things that are heavy, 4 plus 4 is 8, 4 protons and 4 neutrons, but calcium has 20 protons and 20 neutrons. So that's really 40 things. So isn't calcium going to weigh a lot more than beryllium? So if one calcium atom weighs more than one beryllium atom, certainly this many calcium atoms would weigh a lot more than this many beryllium atoms. So anyway, hopefully that sort of makes sense to you. The explanation of grams and moles is actually a lot harder than working the problems. So we're going to transition now to the notes. And again, if you're in my class, you have these notes. And so let me show you my method of how to work these problems. And it's really simple. Even though that explanation was kind of lengthy and complicated, working the problems is a breeze. So let's start off with 11.2 grams. See, this question says, if you have a sample of NaCl with a mass of 11 grams, how many, I'm going to circle this, how many moles is that? If I have 11.2 grams of NaCl, how many moles? So you're always going to start with what's given in the problem. This time it's 11.2 grams of this stuff. And I make my kids always write the unit and the compound. The unit is grams. The compound is NaCl. You know, you might in another problem have a unit of liters and a compound of oxygen. Or you might have, I don't know, atoms of beryllium. But this is the unit and this is the compound, and I want both written when you do these problems. So you start off with 11.2 grams of NaCl. I'm going to do another dividing line, and I'm going to bring down the unit and compound automatically. Without even thinking, I'm bringing down grams of NaCl. Even though I don't know what to do next, I know to do that. Whatever is the unit and the compound gets brought down in the next box over at the bottom, kind of in the corner, so I can still write a number there. Well, the question says I want to go to moles, so maybe at the top I'm going to write moles of NaCl. And then for dimensional analysis to work, and I've taught this in the past, the things at the top and the bottom have got to be equal to each other. And so I'm going to say I've got 1 mole. If I don't know what to put at the top and it's moles, I'm going to go ahead and put a 1. So for right now, in front of the word mole, we're always going to put a 1. Now later that's going to change, but for right now it's going to be a 1. And then the thing at the bottom has got to equal a mole. Well, if I have a mole of NaCl, this is a little confusing, but think about it. If I have a mole of NaCl, don't I really have 1 mole of Na and 1 mole of Cl? So I sort of have 2 moles inside of a mole. The mole of Na and the mole of Cl, right? Well, let's go back and look at our periodic table. The grams of Na, the gram number is 22.989770. I'll let you round that to 23. So really I have 23 grams of sodium, but then I also have a mole of chlorine, so I've got to add the mass of it, 35.453. So essentially I've got 58.43 grams, I'm sorry, that was wrong, 58.45, not 43, would be better. 58.45 grams equal 1 mole. So then the grams of NaCl would cancel, and I'd be left with the unit that I want. And now I'm ready to do the math. And when you do the math, all you do, we've done this before, is type in 11.2 times 1 divided by 58.45 equals, and I get an answer of 0.19. 2 places past the decimal is fine in my class. And I've got to write the unit. Moles of NaCl. And that is the answer. Now, you're probably really confused at this point in time, and that's okay. Let's just keep working problems and see what happens. The next problem I've got says I have 55.1 grams of SO2, and I want to know how many moles. So let's just start off and say 55.1 grams of SO2. And right off the bat, I remember that Mr. Stewart says always bring down the unit and the compound. So I'm going to bring down grams of SO2. And since I want moles, I'm going to go ahead and write moles of SO2 up here. I don't know what to put for moles, so I'm going to put a 1. And then grams of SO2. That means this time I've got to take the number for S, which is 32, and then O, which is really 16, because 15.9994 is 16. But really what I've got to do is I've got to double this number, because my formula was SO2, not just SO. So that's 2 oxygens and 1 sulfur. So if I add that together, we said that oxygen was 16 times 2 equals 32, plus the 32 for sulfur is 64. So I've got 64 grams of SO2 equal 1 mole of SO2. That was a little fast. Let me do that one more time. The formula is SO2. I need 1 sulfur and 2 oxygens. If I look at my periodic table, if you'll look along beside me, for sulfur it should be 32. So I'm going to add 32 plus, maybe I'll open parentheses and say oxygen is really 16 because it's 15.9994, so really 16. But there are 2 of them, times 2. Close equal. That number goes in the bottom. 1 at the top. Now my grams cancel and I'm ready to do the calculation. 55.1.1 times 1 divided by 64 equals, and the answer is 0.8, I'll say 0.85 moles of SO2. I rounded, it was 0.84769 something. 2 places past the decimal is fine for me. It doesn't need to be more than that. All right, let's try another one. Actually, this one works exactly the same. Number 15 is BF3. So I'm going to go ahead and let you try that on your own. Give that a try right now. Just stop the video and pick it back up and see what you think the answer would be. So pause it right now. Give it a try. All right, if you tried that one, you should have gotten 5.26 times 10 to the negative 1 moles of BF3, which is the same thing as 0.5, well, really 0.53, because see that 6 would round that up. So 0.53 moles would be an acceptable answer also. Either of these would work out fine. If you want to see how that one works, I guess I could squeeze it over here. It would have been 35.7 grams of BF3, and it would have ended up being, if you did the calculation, 67.81 grams of BF3 to 1 mole of BF3, and then when you did your calculations, that's what you would have got for an answer. Okay, now 16 is going to work a little differently. Notice this one, I start with 3.20 moles. And guys, I'm going to change this. I'm sorry, but that's just too much to write. Change that ZNO to, we'll just make it Cl2. That'll make it a lot easier. So 3.20 moles of Cl2. And we're going to go ahead and write moles of Cl2 right off the bat. But now I'm asking for the what? Mass. So I'm going to put mole at the bottom, and mass always means grams, by the way. So I'm going to put grams of Cl2 at the top. Now I got to think, where's my 1 going to go? Does 1 go with mole or with gram? Well, 1 goes with mole. And so I got to say, how many grams are there in a mole of Cl2? So I go over here, I look at my periodic table. There's right there 35.45, but there's 2 of them, so I've got to double that. I'll go ahead and do the calculation here for you. 35.45 times 2 equals 70.9. So that number goes on the top. And then I'm ready. I mean, moles would cancel. I'd be left with grams. That's what I'm asking for, is mass, which is grams. So I'm ready to do the calculations. And I do 3.2 times 70.9 equals, and I get an answer of 226.88 grams of Cl2. See how easy that is? No problem at all, right? All right, next problem. We're going to change this. This is too much to write. Just make it the letter S for sulfur. Let's just make it S. It'll be a little bit easier to do. In the future, I may have these corrected where you don't even have to make the revisions. I may correct them, and so next year they may already have the notes may be corrected when you start to work them. So let's start with 8.1 times 10 to the negative 1 moles of S. Right now, I know he wants me to bring down mole of S, and again, he wants me to go to mass, so that's grams of S. I know he wants me to put the 1 with the mole, and I just got to look on the periodic table and find S, right? It's right there. What's that number? 32. So I put 32 at the top, and I do the calculation. Now, there's something new I want to talk to you about. See how in this problem, see how this number has got an exponent of -1? I want my students to always use this calculator, TI-30X2S, and do it my way, which is anytime that you have a number that includes an exponent, I want that number in parentheses, and we're not going to use times 10, we're going to use the second EE button. So we're going to do open parentheses, 8.1. Hit the second button right here. Second, and then go down to above the 7. See where it says right here? Do you see that EE right there? We're going to do the second button and then the EE. And that's going to give you a single E. And then type in the power, which is -1, close, and the times 32. So that's going to be this times this. And then we're going to do divided by, so don't hit equal, hit divide by, go down here to this 1, and hit 1, and then hit equal. And you should get an answer of 25.92 grams of S. And that'll be your answer. Now, I understand that you didn't really have to divide by 1 because when you divide by 1, it's the same answer. But I'm teaching you a method that works over and over. I want you to get in the habit of doing it that way and hitting that divide sign by 1, because in the future that's going to become important when that's not a 1 there. So that's why I'm doing that. All right, let's do another problem. Number 18. I have 2.4 times 10 to the -2 moles of CCl4. And I'm trying to solve for mass, which is what, again? I forgot what's mass. Oh yeah, mass is grams, right? Not grandpa, grams. That's a good one, not really. All right, so I'm going to bring down moles of CCl4, and I'm going to put grams of CCl4. So again, these two things have got to be equal to each other. I don't know a number to put for moles, so I'm going to put a 1. And then for grams, I've got to add 1 carbon and 4 chlorines. So the easiest way to do that, if you look at your periodic table, you should see the number 12 for carbon plus, open parentheses, let's do chlorine 35.45 times 4, because we said there are 4 of them, right? CCl4. So that number, the number at the bottom, times 4, close parentheses, equals, and then the molar mass, or the grams, is going to be 153.8 grams equal a mole. Well, now I'm ready to just cancel, right? And do the math. So again, remember I told you I wanted you to start with opening parentheses. 2.4, second, and then the E button right here. See it? Right there above the 7. Second E. And the calculator should show an E if you've done it right. Then type in your exponent, which this time is a -2. Close. Times 153.8. Divide by 1 equal. And the answer should be 3.69 grams of CCl4. 3.69 grams of CCl4. All right, let's continue on. I'm just about to wrap up this video because I know I can only have you for so long before you get tired. But let's try, let's see, that was number 18. Let's try 19. Now 19 is going to work differently. I'm going to throw you a loop here. You have 4.7 moles and you want to know molecules. Now remember that 6.02 times 10 to the 23, that number can go for 4 things. It can go for atoms, it can go for molecules, it can go for particles, or it can go for formula units. And to be honest, I'm not really sure what the difference in these 3 are. They're just different ways of saying the same thing, but in chemistry we got to use as many words as possible to confuse kids, so that's what we do. And atoms is kind of the same thing. I mean, all of these go with this number, so to speak. So watch how I work this problem. I have 4.7 moles of PCl3. Well, I'm going to bring down mole of PCl3, and then instead of doing grams at the top, which I could do grams, but that wouldn't really help me, I'm going to go ahead and write molecules. And the abbreviation is MLCS, molecules of PCl3. Well, again, if I don't know the number for mole, I'm going to put a 1. But instead of looking at these numbers, for the masses of P and Cl3, instead of doing that, I'm going to say, wait a minute. I remember that Mr. Stewart said that molecules are this number right here. So I'm going to put 6.02 times 10 to the 23rd right there. Now my moles cancel and I'm left with molecules. So all I got to do is the math. If I start out, I want to start out by saying 4.7 times, open parentheses, 6.02, right there. The second button, right down here, the EE button. I should have an E right there now that I can see. Type in the 23, close, divide by 1 equals, and there's my answer, 2.83 essentially, because the 9 rounds it up. 2.83 times 10 to the 24th. And then the unit is going to be molecules of PCl3, and I'll circle that. Right? It's not bad, is it? Let's try this one. This one says, how many formula units are in 3 moles of this? Now I'm not going to leave that. We're going to change that to, let's make it easier. Let's see, number 19. Let's change that to just Ca. That'll be way easier. Okay, so I'll start with 3 moles of Ca. Moles of Ca, and I'm going to do formula units of Ca. 1 mole there. Formula units is one of these 4, so I'm going to write this. And I'm going to calculate it. 3 times, open parentheses, 6.02, second E, 23, close, divided by 1 equals, there's my answer, 1.806 times 10 to the 24, and it's formula units of Ca. That one's done. All right, let's skip number 21. Actually, you try number 21 on your own and get an answer. So stop the video right now. And let's also change, let's change this. Change this to just water. That's easy. H2O. So just make it H2O there. All right, try number 21 now. All right, if you worked it, you should have gotten 2.47 times 10 to the 24th. And that's going to be particles of H2O. And if you want me to work that real quick, I'll just be quick with it. Mole of H2O. I remember that particles is one of these things up here. So that 6.02 number goes with particles. And then when I multiply this times this, I get that answer. All right. The next problem that I'm going to introduce, and my next video will show you a little bit more of this. No, I'm sorry. No, before I go to that, let's do number 24. We'll do 24, and then I'm going to call it quits on this video. 24 is going to be, I've got a piece of marble that contains this many molecules of calcium carbonate. I'm going to change that. Let's just change it to CO2. It doesn't matter what it is, so that's easier to write. Okay. So I have this many molecules of CO2. How many moles is that? So I start off with 8.74 times 10 to the 23rd molecules of CO2. So right now I know I've got to bring down the molecules of CO2, and I want to go to moles. So that's going to be moles up there, isn't it? Now what number? Uh-oh, can't see that, I'm sorry. So I started with the number, molecules of CO2. I brought down the molecules of CO2 to moles. What number goes in front of molecules, do you remember? Oh yeah, it's the 6.02 times 10 to the 23rd to 1 mole. And then I'm ready to do my calculations. Now this is going to be a little bit more challenging because I'm going to start off by putting this in parentheses, 8.74, second E, 23, close, times 1, divided by open. 6.02, second EE, 23, close, equals. The answer is 1.45, and it's mole of CO2 is the answer. Because again, that and that cancel. All right, one more. I know I told you the last one was going to be my last one, but I want to work one more. I'm going to go back up to number of atoms. Okay, we'll try number 26. If you want to work the other ones out, if you work number 22, just by chance, the answer would have been 1.69 times 10 to the 24th atoms of F. So if you really care about chemistry, you want to go back and try that problem on your own, you can. Number 23, just disregard that. I never worked that one out. I didn't leave myself enough room. 25, this answer would have been 2.17 times 10 to the 23rd atoms of P. So you could try that one as well. It's pretty easy to do. And then I'm going to work 26, and then I'm going to stop there. So 26 is going to be, oh, I'm going to mark that out too. That's too much to write. Mark this out and write BF3. I just don't want to write that many elements down. Okay, so how many moles in this many formula units? So I know I want to start with the 7.9 times 10 to the 24th formula units, and I've got to write the compound, BF3. So right now I know I want to bring down formula units of BF3, and I'm going to moles, so I'll go ahead and write mole of BF3. And I don't know any number to put for BF3 for the mole, so I'm going to put a 1. And then formula units, wasn't formula units on our list over here of that number? So I'm going to go ahead and write 6.02 times 10 to the 23rd. And then I'm going to go ahead and do my math. Clear this out. Got parentheses. 7.9, second E, 24, close parentheses, times 1, divided by, open parentheses, 6.02, second E, 23, close, and equal. And I get an answer of 13.12 moles of BF3. So there you go. Now class, before I finish, the last thing I want to mention to you, I know this has been a long video, but let me just say this and then I'll get off. On these problems, you cannot look back at the way you worked the previous problem and say, well now wait a minute, last time I had the one at the top, or last time I had 6.02 times 10 to the 23rd at the bottom, and now you want it at the top. I don't understand. You can't do that. You've got to use your logic. You've got to remember the rule about bringing down the unit and compound and then putting whatever number works in that situation. Every problem is going to work differently. You can't go back and memorize what you did the last time. You've got to think it through and use the logic that I've taught, and you'll be sure to get them right. If you're still confused, don't worry, don't sweat it. Go back and watch the video a little bit again. Come talk to me in class. Do the best you can. Starting tomorrow, I'm going to teach you how to go from grams to molecules. So you'll have to go from grams to moles and then moles to molecules. It'll be a two-step process instead of a one-step process, but it's still not terribly hard. So with that said, I hope that it helped you today. Hope you got something out of it. If not, you can come to me and tell me that I'm a horrible teacher. Peace out.